In section 6.2, we're going to take the ratios and proportions that we began working with in section 1 and begin to apply them to different types of geometry problems. Okay, but some additional properties of proportions that we're going to take a look at here. The first one's called the reciprocal property. So if we know that A over B is equal to C over D, then we can just take the reciprocal of both sides, and those two would have to be equal to each other. So it'd be B over A equals D over C. Just take the reciprocal of both sides. Okay. Example 2 here says if you interchange the means of a proportion, then you form another true proportion. In other words, if A over B equals C over D, then C over A equals D over B. C over A equals D over B. Again, these properties are just coming down and telling you that there's more than one way to set up a proportion and solve. Okay, when we start looking at some of these problems. So number 3 says in a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. In other words, A plus B over B equals C plus D over D. All right, we won't use that property as much, but still one that is valid. Okay, so in example 1, we're just going to copy and complete the statement. So we're just going to kind of identify these properties at work. So if 7 over 10 equals x over 7, then 10 over 7 equals y over x. Just take the reciprocal of both sides. If 3 over x equals 9 over y, then 3 plus x equals 9 plus y over y. That's the property that says add the denominator to each numerator. Okay, part C, if 6 over x equals x, if 6 over x equals 24 over y, then 6 over 24 equals x over y. Okay, equals x over y. Part D, if x over y equals 5 over 11, then x plus y equals 5 plus 11, which is 16 over 11. Right? Again, that's the one where you add the numerator or denominator to each numerator. Part E, if 6 over x equals 5 over y, then 6 over 5 equals x over y. Just be consistent. And finally, part F says if x over 4 equals 7 over y, then x plus 4 equals 7 plus y over y. So again, these are just identifying those properties at work. Okay, example 2 says write 4 true proportions. Okay, so in other words, we have the given one, so we know this is true. AC over DF equals BC over EF. That's one. A second one is I can take the reciprocal of both sides, so DF over AC equals EF over BC. And then I can take, I can go ahead and say, okay, BC over AC is equal to EF over DF. And then over here, I could say that DF over EF is equal to AC over BC. So there's 4 true proportions that have to be true given this guy. Okay, part B says solve for x, so I can use any of these proportions. It won't make a difference. Let's just use the one that they gave us. Okay, so I know AC is 12, so I have 12 over DF, they tell me is 18, equals BC, which is 9, over EF, which is x, and then just recall, to solve this guy, we're just cross-multiplying. Okay, so when I cross-multiply, I get 12x equals 162. I have one extra one there. Divide both sides by 12, so x equals 13.5. Okay, pretty straightforward stuff. Okay, nothing too crazy yet. Example 3, part A in the diagram, JL over LH equals JK over KG. Find JH and JL. All right, so I'm gonna obviously if they give me this, I'm probably gonna use it. So JL, if I look at JL, now here's the trick. JL is this blue segment right here. And so you have to do a little bit of thinking here because the whole length is x. If this much is 2, that makes JL x minus 2. Okay, so JL over LH, which is 2, equals JK, which is 15, over kg, which is 5. Cross multiply and solve. 15 and 2 makes 30. When I cross multiply this way, make sure you distribute the 5 so you get 5x minus 10. And then you're just using algebra. Add your 10 to both sides. 40 equals 5x. Divide both sides by 5. X equals 8. Okay, that doesn't answer my question though. Question is find JH and JL. Alright, so JL, or let's see here, JH is 8. The whole length is 8. So JH equals H, and JL is 8 minus 2, which is 6. Part B, similar problem. Again, they give us the proportion, so let's use that. So KL, so they say KL over GH is equal to JK over JG. So KL is 12 over GH, we don't know. Call it X, it doesn't matter. Equals JK is 15, and JG now is 15 plus 5, which is 20. Cross multiply and solve. You get 15x equals 240. Divide both sides by 15. So x equals 16. 150. Let's see here, 210, 240. Yep. So x equals 16. So GH is just 16. That's what x represented. So GH is 16. Done. Okay, it says find each value. Given AB over BC equals AE over ED, find BC. Okay, so again, use it. AB is 6 over BC, we don't know. We'll just call it X. We don't know it. Equals AE is 12 over ED is 4. Okay, and then you cross multiply. 12x equals 24. Divide both sides by 12. So the value of x here is 2, and that was BC. So BC is just 2. Part B says given the proportion, find BC. Okay, so AB is 12 over, we don't know what BC is, call it X again, or you could just leave it as BC, it doesn't really matter. Okay, so in other words, if you wanted to just leave it as 12 over BC, because we don't know it, leave it like that, that's fine. AE is 18 over ED now, right, is this piece, so we got to do a little bit of work, we got to do 33 minus 18, which is 15, and then we cross multiply, so 18 times BC equals, let's see here, 12 times 15 should be 180. And then divide both sides by 18. So the length of BC here is just 10 units long. Okay. And then finally, part C. Again, we have a proportion that we're given. So we have AB, which is what we don't know, over BC, which is 5, is equal to FE, which is 4, over ED, which is 6. Cross multiply, 6 times AB equals 20. Divide both sides by 6. So AB is equal to 3 1/3. So we'll just go ahead and leave that as 10 over 3. Okay. So AB is 10/3, 10 over 3, and so the length of AC would be 5 plus that. So you could say 5 plus 3 1/3, which is just 8 1/3, 8.33 repeating. So again, this is how we're using simple proportions to solve for geometric problems. Example 6 here, which is actually example 5 on your notes, it says Mike buys a 3D scale model of the Sun Sphere in Knoxville, Tennessee. The actual building is 266 feet tall. Mike's model is 20 inches tall, and the diameter of the dome on his scale model is about 5.6 inches. What is the diameter of the actual dome? So you got to set up a proportion here. And the way you do this is you would do actual height, and you can do it a variety of ways, but you can do actual height over actual diameter equals model height over model diameter. And again, this is not the only way to do it, but this is the way I would choose to set this thing up. And so now you just plug in what you know. Okay, do I know the actual height? I do. It's 266. Okay, I don't know the actual diameter. That's what I'm trying to find, so I'll call it x. I know the model height is 20 inches. Okay, and I know that the scale model is the diameter is 5.6 inches. Okay, and so there's a few different ways you can do this. You need to recognize that this is in feet, this is feet. Okay, these are inches and inches. So as long as you're consistent on both sides, you're fine. Just know that your final units here are going to be in feet. Okay, so when you cross multiply, you get 20x equals 5.6 times 266. 5.6 times 266 is 1,489.6. Divide both sides by 20. And so you get the actual diameter to be roughly 74.48 feet. Okay, and so again, just an example of how you can use proportions to find different lengths in various problems. Okay, part B here says how many times as tall as your model is the actual building. So again, your model is 20 inches and your actual is 266 feet. Okay, so what I would do is, it depends on how you want to do this, but the question is how many times as tall is your model than the actual building. So I would convert this first to feet. Okay, so when I convert that to feet, 20, side note, 20 divided by 12, okay, is going to be, let's see here, it's obviously going to be 1 foot 8 inches. But if I want to leave that as a fraction, I could just reduce it down to 10 over 6, which is actually 5 over 3. So this is feet, right? 5/3 of a foot, so it's actually 1 2/3 feet. And so you have 5 over 3, that's your model, times x, which is how many times as tall it is, equals 266. Multiply by the reciprocal. And so you find that your actual is going to be 266 times 3 divided by 5 is 159.6 times taller. So convert, set up an equation, and solve. Okay, and so that kind of summarizes section 6.2, just using proportions to solve geometric problems. So as always, any concerns you might have regarding this section, bring them to class, and we'll be sure to address those things first thing.